How do folded layers trap oil and gas? So in this case, we're looking at an anticline, and the way I always remember anticline is that the arms of the fold bend down away from the axis, and so they look like the letter A. And an anticline is a fantastic place to trap oil if you have the right sequence of layers. Okay, most anticlines are shaped like an A. Oil and gas migrate up the flanks of the anticline through a permeable unit, and in pore spaces between sand grains and along bedding planes and fractures, that's where the oil accumulates, and this is what we call, again, the reservoir rock. It's trapped in an anticline below an impermeable layer that we call the cap rock. So we need to have these different pieces in order for folded layers to trap oil and gas. So a reserve or a reservoir rock is a rock that accumulates hydrocarbons. Okay, that just means petroleum. A rock that accumulates hydrocarbons. Oil and gas fields are the areas where the reserve rock is found. Okay, so it's the area on the surface where you would be putting in your wells, where the oil and gas field is the area where the reserve rock is found. Alright, and you don't have to have a fold, an anticline, to trap oil and gas. You can trap it at a salt dome. So let's look at how that happens. Okay, salt gets deposited along continental margins and other settings in layers that get buried. So think about as the ocean level drops, as sea level drops, you might have areas of the sea that are evaporating rapidly, and you'll get a big salt deposit. And that gets buried by more layers, and the salt is a weak geologic material, so it flows when subjected to forces. So as you're piling up more layers on top of that salt, the salt begins behaving like a fluid, and it will flow. So the salt flow heals fractures and makes it impermeable, but the salt is soluble. So the salt can dissolve in water, however, it's impermeable, so nothing can move through it. Okay, so because nothing can move through it, you can get oil and gas trapped on the sides of the impermeable salt dome. Okay, and it's a dome because it's pushed all the layers above it up, and you can end up getting mountains right over top of salt domes. Okay, so again, the rocks above the salt dome get bowed upward, and petroleum can get trapped in top of the dome as well. Because now, over that salt dome, we have an anticline. Okay, so in this area, you can either find it along the sides of the salt deposit, or you can find it in the anticline above it. Other ways petroleum is trapped. There are many other ways to trap petroleum. The bottom line is you need permeable rocks overlain or partly surrounded by impermeable ones. Okay, so all of these examples here are just that. They're permeable rock, overlain or partly surrounded by impermeable rocks. So let's take a look at some examples. We've got the normal fault. We have juxtaposed layers against impermeable granite. So this is not very fractured granite, meaning you're not going to lose your oil in those fractures, but all of our sedimentary layers were faulted in, were moved along this fracture so that now they butt up against this unfractured granite. Thrust faults. Folds form as layers pushed up bends or steps in thrust faults. So you end up getting oil in the anticline. Okay, so as you push these two blocks together, one of them rides up over the other, basically. So that's what the thrust is where it's moved up and over. And so as a result of that up and over movement, you can trap oil below the impermeable layer. Unconformities. You must have an impermeable unit on top. And so what would have happened here, the sequence of events, would be you had your reservoir rock deposited, all of those layers that were originally horizontal tilted, then you had erosion occur on top of that tilt. That's what all these little rocks and this wavy line here is. And then you deposited something impermeable on top, so something like shale. And because our permeable units are at an angle, the oil can flow up and pool against that impermeable caprock. And the same thing for lenses. For a sand lens, all layers eventually end. So, for example, if you have a beach depositing sand, there is an end to that beach, right? As you go inland, that sand stops. As you go out towards the sea, that sand stops. So where that sand intersects another unit, so for example, as if you're walking out into the ocean, that sand is going to stop just offshore, and it's going to transition into mudstone. It'll transition into clay particles where the waves are not so active. Because with less energy, the smaller particles can settle out. So where that happens, you get what's called a lens. And so again, it's just that combination of permeable rocks overlain or partly surrounded by impermeable ones. That's all it takes. All right, let's observe petroleum basins in the U.S. Where do we find petroleum? We get some small basins producing larger amounts of oil than larger basins. So that's something to keep in mind. Even though it's a small location, a small basin, it can still be generating quite a bit of oil. Texas and central western parts of California are the areas that have lots of oil here. Okay, so we've got Texas and Gulf Coast areas, and then central western United States and parts of California. The top producers are going to be found in Alaska. So that's one of the big deals politically, is getting that oil from Alaska, distributing it, processing it, and avoiding devastating that ecosystem there. Okay, so again, the top producing oil field in the U.S. is in Alaska. That's Prudhoe Bay, Prudhoe Bay in Alaska. Right, but we also find them in Texas, in the Gulf Coast here, in the central western U.S., and parts of California. And remember these locations because we'll be coming back to this in just a second. How does coal form? Coal needs an environment where plants grow and accumulate in large quantities like a swamp. You must bury the plant parts and not destroy them by oxidation. So again, we need an anoxic environment, meaning a low oxygen environment. Burial causes increased pressure that compresses materials and temperature that drives off more volatile materials. burial and heating increases carbon content of the coal. So over time, as you get to these different grades of coal, you're getting more energy out of the coal, and that's called maturation. Anthracite has 92 to 98% carbon and occurs in rocks that have been moderately metamorphosed. So that's our highest grade of coal, is the anthracite. So let's go through them real quick. We've got peat, which is unconsolidated plant remains found in bogs. This is our lowest grade coal. It's not even packed together. It's just loose, slightly decayed plant material. The next grade is lignite. Lignite is a brown, not very dense coal. Next, as we continue increasing pressure and temperature on these deposits, we're getting better and better coal out of it. So the next one is bituminous coal. It's a black, fairly dense coal. And then the one that I mentioned already, anthracite, is black, dense, and shiny, and it has the most energy for the amount of material. So overall, how does coal form? It forms from buried and compacted plants. And what is methane? Methane is a form of natural gas. It occurs with decay of plant material. Okay, so those are our types of coal. How is coal mined, transported, and used? Coal is mined in large open pits when it's close to the surface, or from underground mines in coal seams. So a strip mine is just an open pit mine, meaning it's open to the surface. And again, that only happens if the deposit is close to the surface. They strip off and save what's called overburden, which is anything that's on top of the coal. They're going to keep it, including soils. They mine the coal and then reclaim the land with that overburden from the next strip. So when that mine retires, they fill it back in. Hypothetically, that's ideally. The old mines, that was not the case, and so there's still a lot of these really big open pit mines around the state. Underground mining is more expensive and more dangerous, so it's used for better coal varieties. So this is more like the mining they have back east, and you hear about it in West Virginia and other places. Typically, there are a lot of hazards with underground coal mining, like explosions from the methane that occurs naturally near the coal, and collapses and people being trapped and that kind of thing. As far as uses, coal is burned to convert water to steam and generate electricity. As far as being transported, the coal gets hauled to the surface, it's crushed, stockpiled, and then transported by train, truck, or cargo ship to wherever it's going to be used, typically power plants. Observe where coal and coal bed methane occur. So this map shows coal-producing areas which also produce coal bed methane. And the color is according to the type of coal. So we've got this tan color that's lignite, the gray color that's bituminous and subbituminous coal, and the black, which is anthracite. So if you look around all over the U.S., the highest grade coal, the best quality coal, is the most rare. So you can see in the East Coast, the anthracite belt is the only location really we can find anthracite in the U.S. Younger coals are less deeply buried, and the Colorado Plateau and southern Appalachians are the largest producers. Okay, so how does this compare with where you find petroleum basins? So remember that map with the petroleum basins. We had Texas, the Gulf Coast, the western U.S. So there are similar regions and some overlap. So if you think about the environments required to produce coal, which would be near the coast, in swampy areas, and the environments necessary to form petroleum, which would be oceans, as the sea level moves around, you're going to end up having overlap of both of those, right? If you think of our current Gulf Coast, the coastline of Louisiana, for example, there are all sorts of swamps in Louisiana, but if sea level should rise very quickly, then we'll have ocean deposits on top of that swamp deposit. So we can potentially be forming petroleum on top of coal. Or if the sea goes out, the sea level drops significantly, then we'll have wetlands or swamps extending further out away from the continent and depositing on top of what may have been previous petroleum deposits.